In this video, I will demonstrate how to graph these problems in ALEKS. Now remember, whenever you're working in ALEKS, you need paper and pencil. You need to write the things down as I've been modeling in my notebook, do the math that goes with it to make sure that you're graphing them correctly. However, for this video's purpose, I don't want to switch back and forth to my notebook, so I'm just going to use the tools here and talk my way through it. So when you're graphing a system of inequalities in two variables, what you want to do first is graph each one of the related equations. So I know this is going to be a parabola. The second one is going to be a line. And the third one is going to be a constant function or horizontal line. So I have to make sure I choose the appropriate tool. So for the first one, I'm going to grab the parabola tool. It wants me to place the vertex. Now this is a parabola that has been shifted down 2. So that means I'm going to place the vertex at -2, 0. Whoops. Better do that again because that was not right. So I'm going to pick up the parabola, place it at -2, 0. It's going to open up, so I'm going to click above, and then the other point is usually at, see if I plug in 2, 2 squared is 4, and 4 minus 2 is 2. So that looks like the right parabola. Yeah, because 2 is usually at 4, but it's been shifted down 2 as well. Now, before I leave this, I want to go back and check the equal sign is a part of this inequality. So that means the curve should be solid, and it is. Let's look at number 2. Number 2 is the line, or the related equation is y equals x. So y equals x is the untransformed line that sits at the vertex. So I'm going to pick up the line tool next. One of the points is going to be 0, 0. And then it will also sit at 2, 2, or I could place it at 4, 4, or 6, 6, because this line says whatever x is, y is. So I'll place another point here. Then I need to check, this one does not have the equals to, which means I need to grab this dash tool, make sure I'm pointing on the line and click, and it will make the line dashed. Now the last equation in this system, or related equation, is y equals 5. That's a line. I'm going to pick it up. I'm going to place one point at 0, 5, and then it is a horizontal line. So if I could place it at -2, 5, -3, 5, it doesn't really matter as long as it sits at y equals 5. Now that one does have the equals to, so it will be solid. Now I can use the inequalities to determine my shaded regions because these are all solved for y with y on the left. So that means I should be shading above the parabola, so it's going to be inside the parabola, above this dashed line, y equals x, but then below, because this one is less than, the line y equals 5. Now, this computer's kind of smart in that it knows exactly where you want shaded if you just put it in the right region, because it does not shade down here because that would be below that dashed line and it needs to be above. It does not shade above here because that would be above the horizontal line and it needs to be below, and it does not shade below the parabola. But when you're doing this by hand, and we're going to do some in class next week on a classwork, you'll need to know exactly what region to shade. So I believe this is right. Wish me luck. Whoops, I think my check is hidden by this. So I can't check it in front of you. Whoop, there it is. Let's see. Yay, we got it right. So that is how you do these graphs in ALEKS.